So we're here looking at my house right now, and I'm just kind of finishing up a pretty major structural repair that I had to do, and I want to make a video to try to share this with other people and hopefully teach you something about what holds your house up, really. So I've lived here about 4 years now, and when I bought this house I had to redo the siding. It was in terrible shape. Hopefully if I can figure out how to edit a video, I'll throw some pictures in there of what it looked like before. Now this type of siding is a Hardy Board product. Comes in 4x8 sheets. They were actually pretty cheap, and they were like 65 bucks a sheet. And Hardy Board is like a concrete product with reinforcement mesh in it. Now when I took this wall off, there was a big bulge in the bottom right side of it. I don't think the sun's working with me right now, but that fake column right there, that's not an actual column. It's just 1x is formed into a column, but it was bulging out, and it's kind of hard to see now. And in fact, it's actually, I've improved that, so I don't know if it's going to pick up in the camera, but that is not a load-bearing wall. That wall, and I'm going to show you how to figure that out, that's a gable wall, and it's technically not a load-bearing wall. Now, the way to tell if something's load-bearing for pretty straightforward construction is the walls that the rafter come down and land on top of are carrying the load of the house, basically. And this is in normal construction, normal modern framing. The floor joists are supposed to run in the same direction as the rafters. I've seen some builders do it differently, but it's really not the ideal way to do it. So you can see the rafters are coming from the top middle of that wall. Hold on, I'm having a little problem with my camera right now. So the rafters start at the peak, land on this wall on the right, and then they're supposed to land directly on top of a wall stud on the floor below. The floor joists are supposed to go right under those studs, and then the bottom floor studs are supposed to be directly under the floor joists. And what that does is it gives you positive pressure from the top of the roof. Basically all the weight of the house is being carried directly through the framing members, and if those are not in line, what you get is a bending stress in the top plates. Like, for example, if the joists above, if the ceiling joists of the floor above are not landing on a wall stud, but let's say in between two wall studs, then that top plate is going to have a bending stress, and you want to avoid that. So anyway, long story short, the whole point of that discussion was to illustrate why this wall over here, where my garage is a load-bearing wall. Those are 12-foot ceilings on the first floor, 8-foot ceilings above. Those are the bedrooms up top. So I have a 16-foot wide garage door opening and 12-foot ceilings down there. On the right side of the house, that's our playroom. So one of the indications I had that there was a major problem was that that piece of flashing on top of the bricks It's a lot better right now, but it was bowing up kind of like that in the corner by the chimney, but much worse. It was raised up. And this is a brick veneer wall, which means it's technically not load bearing, the bricks at least. And you know, back in the day they used to build structures out of brick, but it would be many courses thick and they could take a lot of weight. Right now most construction you see with bricks is wood framing with a brick veneer, it's called. So these bricks go down and they start on top of a ledge that was poured with this slab of my garage. Over there, there's a little step up to the playroom floor, but as I'm going to illustrate, it was pretty poor construction method, and it's what's caused this major problem I had to fix. So let's go inside and look at some of that. Still needs a bunch of cleaning up down here. I'm gonna fill this gap in with some cold patch asphalt and help keep the water away from down there, but I have much bigger problems to address first. See if I can get in here and show you. Now, this floor, this tile is on top of a slab, and notice how they started the framing, which is actually below grade, which can't imagine why anybody would do that. It's a terrible idea, but they did it. So now it looks like this isn't rotted over here. However, I think it is. I think there's a sill plate below that that's rotted, and the whole thing is dropped, because that's why the flashing next to the chimney outside is still raised up. Now I'm going to fix that too. Here is part of what we had to do. This is a temporary wall. It's braced to that wall so it can't move. And there's a temporary beam up on the ceiling. It's pushing up on my floor joists to take the stress off of the wall studs so that I can reframe it, kind of get it back up to where it should be, but not quite as high as it was. I think I'm gonna have to make a little compromise there. So those are post jacks that are rated for 18,000 pounds each at their lowest setting. And that's a triple 2x8 temporary beam up there. And this wall here is perhaps a little under designed, and I think I'm gonna have to beef that up a little bit, but I'll show you what I did in the garage. So we got a lot going on here. Oh, you know what? Before I come in here, I want to show you something else. Now there's a big crack where the wall meets the ceiling up there. That was one of my indicators that I had a major problem here. It's a pretty big crack. I think in most people's houses they would be alarmed by that. But this was the other major indicator over here. I've been watching this crack grow for a couple years now. And over the last 6 months, it's been getting worse, much quicker. So, knowing that this exterior wall is a load-bearing wall, and this wall separating the garage and the playroom is not a load-bearing wall, it's a partition wall. That indicates to me that my load-bearing wall was sinking, and this partition wall that's not holding anything up was not moving. And you can see, I don't know if that's picking up in the video, but this last joist about 6 inches from the wall is dropping with that load-bearing wall. And there's not even a joist on top of this partition wall. So the sheetrock cracked right there, and up in that corner there was a good inch of drop. So that combined with the flashing above the bricks was enough to tell me that there's a major problem going on. So first thing we did was cut open the drywall down here in this corner, and what we realized was how low they put the sill plate, and it was all rotted. These studs that were here, and I'm going to throw some pictures up of them if I can figure out how to edit a video. There's nothing holding up this entire garage opening. Now, that above the garage is a header made out of two 2x12s with a 1/2 inch thick metal plate sandwiched between them, bolted every 16 inches. I'm pretty sure every stud above it has a bolt going through. Pretty typical header for a garage door, although nowadays it would be made out of LVL probably. But this 16-foot opening is carrying all the weight of the bedrooms above and the attic above that, all the framing, all the flooring, drywall, siding, shingles, everything above it. All the weight's supposed to be transferred straight down through the framing all the way to the foundation, and there was nothing left holding it. This header was just floating, and I'll be honest, I don't know what was holding my house up. Could have collapsed. So what we have going on here is I replaced all of the, cleaned that out really well, put some pictures into that, and we threw in a bunch of pressure treated wood that hopefully won't rot. You never know though. We anchored that to the ledge on the bottom of the slab and just kept building it up with pressure treated. Talked to a mason friend of mine who said that you don't really want to use concrete since it's not a thick pour. You don't know if it's actually going to be strong enough. So we just did pressure treated, and then I went back and we had some gaps because I couldn't fit a 2x6. I had to rip it down, but there was still some air space in there that was below grade, so I filled it in with a bunch of self-leveling concrete that you would normally use for floors, and I did that just to displace that area where water could get in and sit. So hopefully that will help in the long run. So anyway, getting back to the original framing repair. We built this temporary wall here. It's about 4 feet in from the load-bearing wall on the outside. And got a temporary beam up top to help carry the weight of all the floor joists above it. So originally I built this with whitewood joists, or not joists, sorry, studs, and I put those perpendicular to each other to help give it some extra strength so it didn't bend in either direction. But I went back and added more Doug fir 2x4s. Doug fir is stronger, so I just sandwiched them around it. This bracing is very important here. That holds the top stable so it doesn't buckle once it starts taking a lot of weight. If you have since there's a wall with a separate member that's not really attached up there, you start pushing some weight on that, could easily buckle if there was no bracing there. So these post jacks are pretty good. They're cheap. I forget what I paid, $60-70 for each one. I had like 6 of them sitting around, and I got 3 more, and I screwed them in. The brackets on top and bottom are screwed in, and they've got little raised portions where the post actually goes. Same on the bottom. The plates for the top and bottom are the same, and theoretically the round tube straddles that raised portion and helps to stabilize it, but they're not the best post jacks. There's much better ones. These are just the cheap readily available ones, but they were sufficient. They did the job. Now, so we got this temporary wall in, started lifting up on those jacks. I think I had about 1.75 inches of drop from this metal beam all the way to there. It's an 18-foot span, almost 2 inches of drop because that wall was rotted on the bottom. So I started jacking up the floor slowly, and by jacking up those joists, you're actually picking up everything above it, because the way framing works is on the outside of the house, once they put the framing box in for the floor, which is your joists and the box header on the outside, then they start building the wall above, which is a 2x4 wall. Would have been nicer if they used 2x6s, but this house was built in 1978. I don't think they were doing that back then. But that wall above us is, if it's a single box header, so a single 2x12 box header that all these joists are screwed into or nailed into, then the wall plate above, the bottom plate, overlaps these floor joists by 2 inches. So when you pick up these floor joists, you're actually putting pressure on the wall above as well. So it's not ideal that this was 4 feet away. I would have liked to do it 2 or 3 feet, but then we would have had a lot less room to work over there. So that's kind of the idea. You just build a temporary wall, lift up the weight, and what that did was picked up this wall. I reframed it with 2x6 pressure treated boards, and I was able to fit a longer board in, having picked up this wall. So I don't think I got it quite back to where it was, but it's good enough. And you'll never see any of this once it gets drywalled. So The reason I put that bracing in up there is because I have those post jacks on the outside. I have two 4x6 pressure treated boards and bottle jacks on top of those, and then I also put two more of these post jacks alongside those just for a little extra security there in case the bottle jack's kicked out or something. It's not just floating. Now, our next step, well, first of all, the reason I put the bracing in, as I was pushing up on that header, I noticed that this outside wall was not plumb. And I didn't want that wall to start bending in. It looks like it's actually sloped on the bottom, is a little bit in. And so I didn't want that to buckle basically and push this wall in and then drop the weight. So put that bracing in. Easy, you know, easy task to do, and added a lot of extra strength right there. Then after I got the wall framed, had to add some furring strips up there. You can see the new Doug fir, ripped them to 2 inches and just kind of tacked them into the old studs, and that gives us, we had to bump that out anyway since I'm using 2x6s here right next to the old 2x4 framing. We had to bump that part out too. So then our next step is, I noticed that the garage door header has a slight bow in the middle. It's dropped about 1/2 inch. And while I'm doing all this work, I don't want to mess around. I'm just going to put an angle iron on the bottom of the header. One leg's going to be on the inside. It's going to go up about 6 or 7 inches. The other leg of the angle iron is going to be under the header. So we had to put this temporary beam up because I'm going to have to take those post jacks out from under the header in order to fit the angle iron in. So once we put that angle iron in place, it's going to be making contact in the middle of the header, and there should be about 1/2 inch gaps on either end. We're going to bolt it in the middle where it's making contact. We're going to bolt it up and in the back, and then we're going to put the post jacks back under it towards the middle of the opening, and we're going to start picking up that header. Once we get those post jacks in place, we come inside and we take this temporary beam off the wall. And the reason that needs to be there is for that short period of time when we take those post jacks out to slide the angle iron under there, we don't want the weight to redistribute, and all the weight above this door opening could potentially come back down and break the header. That's the worst case scenario. Now, considering my house was just floating on nothing, basically it was all being held together by the plywood, to be honest, but considering it was basically half of this wall, now this garage is about 23 feet wide, and the rot went maybe 6 feet past that wall into the playroom. You know, this temporary beam might not have been necessary. We already know the house didn't fall over when it was being held up by nothing, but you know, it's not too hard to get a temporary beam up there. And the idea is that the weight above is going to be distributed by this beam, and it's bringing it over to the new studs I put in over here. So the first thing we did was we took a single 2x8 and slapped it across with a laser level. We put it on the studs and screwed it in with these guys here. These are awesome screws. 5 5/8 inch rugged structural screws. Number 12. So the first 2x8 had 2 of those, one on the top, one on the bottom. On each stud, this temporary beam went across. Then we started tacking up more, our second row of 2x8s, staggered the seams on all of them. Forget exactly what we did. This is the middle of the opening. That beam's got the seam for the first board. I made sure to put 2 solid boards over that seam, and we screwed like crazy on this thing. So we tacked up the second and third rows, and then I went back with those big black screws. Let me show you what those are. Four and a half inch headlocks. These things are awesome. Fasten Master makes some of my favorite hardware, and GRK is really good too. But these structural screws here, once that first board is screwed into the framing, we use these to tie the rest of the boards all together. Important part of the design of this screw is that you don't have threads on this part of the shaft here. So as the screw is sinking into the wood, it's 4.5 inches long, so it's made to span 3 2x material. And then these threads on the end will grab into the first board, and this fat head on the back just pulls everything into the last board where the threads are grabbing. So pretty important detail there about how these screws are made. So we're almost done here fixing this house. Fixing the framing at least. Still got to do all the drywall and painting, but you know, now we're my house isn't just floating in the air anymore. It's actually resting on the foundation, and this is all temporarily supported until we get the angle iron in there. So obviously I am in construction and I've done jobs like this before. I will admit I've never jacked up on a 12-foot ceiling, and that was a little hairy because you have to build your temporary wall. It'd be a lot safer if these post jacks were resting on the ground. Let's just put it that way. You have to worry about the wall kicking out on you since these post jacks are resting on top of that temporary wall. But I'm really happy with the way this came out so far. And yeah, we're almost done. Let me show you real quick one more thing I have to do inside. So like I said, I think this is still in danger right here. I'm going to drill through this bottom plate down there, and I'm going to try to see if there's rot below it. I believe there's one more board below it that's rotted. Of course, this heater pipe is right in the way. That kind of sucks. But so the plan here, I'm going to cut these. I move this out of the way. Cut these about 2 feet up, like I did on some of the other ones in the garage, and then slap a board next to it. Once I'm gonna pick up on this post jack a little more until that flashing gets a little better on the outside. Then cut these studs, sister right next to it with maybe a 4-foot tall stud, all pressure treated. Screw it really well to the top 2 feet above, and then slap another board in under the current stud, and I gotta cut it carefully so that it's gonna be hard to fit in place. I'm gonna have to like lift up the house a little bit more just to fit that sistered stud in there. Now I'm gonna do the same thing on the bottom I did in the garage. Clean that all out and put pressure treated boards, probably a few of them, build up the height so it's not below grade. You can see here, there's a step down, and then there's so you can tell that they put the bottom of the framing below grade. So stupid. They should have just poured a little foundation wall to build the framing on top of, but that's what they did. So that's it. That little hole up there I cut is I fit my laser level in there, and I could shoot a line right across this beam I built in here to the garage beam. Right. That's that. It's been a long video, over half an hour, geez. Now, I would not recommend attempting this job if you have not done something like this before. I think I was a little nervous at some points picking up this big house and putting all the weight on this temporary wall, but it worked out for me. God forbid something happened. I mean, it's one thing this house was floating for however long. I think it really, so back to the beginning of this video, I was mentioning the bulge in the wall. That was that wall on the outside. Now, when I had the siding off, I put those pieces of 2x12 in there. It's kind of hard to see with the lighting in here, but there's 2x12s that are running perpendicular to the joists. So I put those in there, and I screwed from the outside to pull that end joist back in. Now, it's not a load-bearing wall, so it should have just kind of come back in for whatever reason. I didn't know why it was bowing out like that. It didn't make any sense to me, but it was about 2.5 inches out, which is a lot. Very noticeable from the outside. I was able to suck it in with those 2x12s. I got it in about 1.5 inches. It was still bowing about 1 inch, and I just ran with it. I didn't want to. I had my siding ripped off. The job was to replace the rotting siding, so I just did that. And I was never really happy with it, but I couldn't figure out what was going on. In hindsight, what I think was happening is there was already rot on the bottom of that wall. And the first indication was this ceiling started dropping and pushing out on that wall. Now, those cracks on my ceiling and the seam between the two walls over there, they weren't that bad. But like I said, I've been watching them get progressively worse for about 6 or 8 months now, quickly. So I knew I had to do something. Now that this wall's fixed, it's hard to see the bow on the wall out there. I think I actually made it even better now that we picked the house back up. But I think the whole point of me making this video is because, you know, some people might see cracks developing in their house and think it's just, you know, that the house is getting old, it's sagging a little, and a lot of times that is the case. But when it's a load-bearing wall, and if you know what to look for to see a load-bearing wall, and you have an indication such as this wall here where, I'll show you a little closer. The floor joist in the garage is on this side of that wall. And there's another one in the playroom about 6 inches away from the wall. So that wall has no floor joist above it. So that has no potential to carry any load. Now, it's technically not a load-bearing wall, but if your sill plate is rotting, if there was a stud on top of that, it would have started to carry the load. I mean, if there was a joist on top of the wall there, that would have started taking up some of the weight. Now, the reason that wall bulged out was because it was taking weight and it was pushing it out. And, I do this for a living and couldn't figure out for the life of me why that was happening. And, and then I'm watching all these cracks develop. I feel like some people would just ignore it. And this house could have fallen over. No exaggeration. The only reason it didn't fall over is because the plywood screwed to the joists or the studs was taking the load from the whole house above it and distributing it sideways until it found a framing member that went down to the foundation. So this was a pretty crazy discovery and pretty crazy job to do, but we fixed it pretty quick. It only took a few days of work to get this all fixed, and I'm really confident this is going to last a long time. It's my electrical service. And then this garage door, this is the northern exposure of my house, by the way. I get zero sunlight. A lot of moisture just sits there. This garage door was always in rough shape when we got the house, and now I'm getting a brand new door after this is all fixed. So I'm pretty excited about that. But yeah, I think that covers everything. We're gonna clean this garage up real nice and do the drywall, fix all that tape. I mean, that could be another issue over there. I've been watching this get worse. I suspect this could actually be related to what we just did. That's my staircase above, going up to the bedroom floor. This is a split level house, so got 12-foot ceilings on this side. I have 8-foot ceilings in the basement over here. And so that difference, you get 4 feet of difference. So these, the bedrooms are above this 12-foot ceiling, and the kitchen, living room, everything else is on this side of the house. So you got this big beam going across here, holding some of the weight of the floor. This wall here is the other load-bearing wall, taking weight from the roof. And I've never looked above these beams to see how the floor joists are connected. I'm assuming they are seamed up there somehow. They gotta be, I mean, they don't have to be, but most likely those are, the ends of the boards are resting just past the beam, so they don't need a single really long 2x12 when they made this house. So you got all the weight from the roof down is being taken by this beam and that outside wall. When that outside wall failed on the bottom and that wall started dropping, it's picking up like a seesaw potentially on this side of the house and causing some kind of movement, cracks or whatever. I mean, I know that the framing's not rotted over here. You can see all the framing from the basement, but I suspect all these cracks, I mean, I got You know, I never really paid too much attention to the ceiling in here. Not like I have been lately, but you got some tape joints coming apart. So once we drywall everything over there, we'll do a nice paint prep and paint job in here, and then I will you know, be able to monitor stuff like this a little better. I can't really see any real issue here. Could also be cold. It's warm, heated on the other side of that wall. It gets cold in my garage, so it could be thermal expansion and contraction. Not too worried about that. So anyway, yeah, this is it. Such a relief to not be worried about this anymore. Honestly, when I opened it up, I was expecting a lot worse. Since that flashing was lifted up on the outside, I was half expecting to find this entire wall just rotted away. But look, it was just the bottom. If the plywood was rotted up at all, then I would have had to take the bricks off the outside and replace that plywood and then redo the bricks. That would have just added a lot of cost. I don't do masonry, so would have had to hire one of my masons to do that. But anyway, hopefully this video is educational and enlightening to some people. These 2x6 walls are super strong now. I got pocket screws going to the plywood because I didn't want to send big screws back to the I didn't want 2 toenail screws in because I didn't want to hit the bricks on the other side of that plywood. There is a gap of about an inch. Probably shouldn't be that much. I think everything has moved a little bit with all this rot and shifting, but so yeah, pretty confident in my fix here. I think it's gonna do the job, and this house is gonna stand up strong for a long time. So that's that. So as promised, I'm gonna do a quick little addition to the video to discuss load-bearing walls, because I really kind of breezed over it and did not give a good description of what's going on with load-bearing walls. Now, talked before about how the rafters come down from the ridge and they land on this outside wall here. Now, this is obviously a simple design here, and this outside wall is definitely a load-bearing wall, and it's taking the weight from the rafters and whatever roof load, snow, wind, anything that's, you know, hitting the house. But the important thing to know is that interior walls can be load-bearing as well. So the way I try to picture it is, you know, the rafters are perpendicular to the ridge. The joists should be perpendicular. Like I said, sometimes you see people build differently. It doesn't make sense to me, but any wall that is parallel to the ridge could potentially be a load-bearing wall. And this gable wall with the, you know, triangular shape in front, it's not really load-bearing at all, because it's only holding up anything that could be, you know, the wall studs on top of it. And if you were, let's say, adding a window on a house right here, you could just cut this stud, throw in some blocking, and it'd be fine. When you are adding something on a load-bearing wall, you have to be a little more careful. Put your temporary walls up, brace it, make sure nothing's gonna drop down and damage the framing. But I also mentioned that the rafters come down and land directly on a stud. That's not really the case. What I was trying to say is that it's directly above a stud. There's a top plate and a bottom plate on walls. That's how they're built. Similar to what I have here. You know, this is a bottom plate, that's top plate, and so the rafter should be landing directly above a stud, but it's making contact with the top plate. The joist, if there's a floor below this, the joist running horizontally, as I have it drawn, should be directly below this bottom plate, but directly below the stud. So it's not quite as simple as I might have made it seem before, but there's another consideration too. This is for simple, straightforward construction. One box, one sloped roof. It gets a little more complicated when you've got portions of the house coming out sideways. Like for example, my house got kind of two different sections of the house. Like I explained, I have the bedrooms with the 12-foot ceilings at grade, and then the other section has living room, kitchen, everything else, and the ridge board is actually perpendicular, so that comes out sideways, and that means that the load-bearing walls would be parallel to the ridge board on that side of the house. But then you have this area where they meet, and you know, things can get a little complicated in there. So it's definitely not always straightforward, and you know, there's plenty of videos out there you can watch and learn more about it. But you don't want to be approaching jobs like this if you don't feel comfortable and know a bit about it. So hopefully that sheds a little more light on that portion. I watched the video I made before, and I had to come back and say something because it was a little misleading, I think. But a lot of people these days want to put beams in their house, knock down walls, and we've done a lot of those jobs lately. So it's definitely good to know what you have to do to prepare for something like that. So another thing about beams I wanted to talk about is they are one of the most important things with a beam is the distance you're spanning. So, you know, that 16-foot garage door opening, that's a pretty big distance to span with a beam. And the further you span, it can become a pretty substantial beam to carry a live load above it especially. But one of the tricky things with beams is that they take a bending stress. That's primarily what they hold up. It forces the beam to bend in the middle, and what that does is it puts the bottom portion of the beam is in tension, the top portion is in compression. So I'll revisit this a little bit here with this garage beam, the header I have. A header is basically a beam, but they just call it a header when it's on an opening like a door or window. So one of the things I noticed on this beam upon taking all the drywall down is I've got these cracks running down right in the middle of the board. It's kind of hard to see maybe, but they pretty much go the whole way, and that kind of makes it a lot weaker, because when a beam is under load and you have the bottom half of it is in tension, the top half is in compression, and if you crack it down the middle, then really you have half a beam left. It's effectively half as tall as it was before. So that's really the main reason I need to put that angle iron under there and reinforce that. But floor joists are essentially beams as well. So they span the opening of the room below them. So for example, you know, I've got this big metal beam here, 18-foot span to that wall. All those 2x12 floor joists are in a bending stress when you're walking on them, and just by carrying the weight of the floor above them as well as their own weight. But you know, about the load-bearing walls on this house, you have that wall, obviously, is the load-bearing wall that I'm dealing with. This wall would be on the opposite side of the house, also a load-bearing wall. Gable side of the house is not a load-bearing wall, with this beam it's not even in the middle. And that's kind of the part I was talking about with a seesaw. But you know, the middle is centered between those two windows. This beam is over here. It is definitely taking a load from the floor above. It's parallel to the ridge beam, but it's not centered on the house. So more of the weight of this portion of the house in the front part, you know, in this garage we're dealing with, more of the weight of this half of the house is tipping this way. So that's kind of why I feel like it might be acting like a little bit of a seesaw over there. You know, that wall getting pulled up might have helped prevent this house from collapsing. But, you know, it's definitely a lot of stress on that plywood, and possibly that side, you know, counterbalancing the rest of the frame. But anyway, I think that's it. Thanks for listening.